Alright guys, we're finishing lesson 10 with 10.2 and 10.3 on page 55. So get your workbooks out and follow along with me. 3 students each attempted to solve the equation 2 times x minus 9 equals 10, but got different solutions. Here are their methods. Do you agree with either of their methods and why? So there's Noah's, Lena's, and Andre's. But first, before we figure out who you agree with, you have to solve this equation. And so you have to take the equation and you have to distribute this 2 to each part in the parentheses. So you have 2 times x, which is 2x, minus 2 times 9, which is 18, and bring down your equals to 10. Then, to get this 18 to the other side, I first have to add 18, because negative 18 plus a positive 18 is 0, so that cancels out on this side, leaving us with 2x. And on the other side of the equal sign, you have to add 18 as well, because it has to be equal to each other evenly. It's kind of like a balance scale. So 10 plus 18 is equal to 28. And then we have to divide by 2 to get x by itself. And so when you take 28 and divide by 2, you end up getting 14. So for Noah, what he did is he added 9 to both sides to get 19 and then divided by 2. But that's not the case of what we did. So therefore, I disagree with Noah because 2 times x minus 9 plus 9 is not 2x. Noah should distribute the 2 before adding a number to each side. So for Elena's method, she applied the distributive property, but then she ended up subtracting 8 from each side before she divided by 2. And as you see in the problem that we did, we added the 18 instead of subtracting. So if you do negative 18 minus 18, that's the same thing as saying negative 18 plus negative 18. And so you're actually going to add it, and it's into a deeper, lower negatives. So the number's going to be higher, but it's going to be farther down into the negatives. So that'll be negative 36. So I disagree with Elena because she subtracted $18 rather than adding 18 to cancel it out. So for Andre, he applied the distributive property, he added 18 to each side, and then he divided each side by 2. In which, if you look at what we did the exact same as Andre. So I agree with Andre he correctly used the distributive property to solve the equation. Okay, and so that's how you do that type of problem. And then now we move on to page 56. And so these are just a bunch of different problems to complete. And so I will do these with you, and then the practice problems in lesson 10 I want you to complete without me. And post your answers in a separate question that I'm going to provide for you, and that will be counted as participation points. So it says two different methods, but I'm going to use the distributive property instead of both methods. But if you need, or if you want to look at this other method, let me know, and I can provide a video of that for everybody. So I have this 2,000 needs to be distributed to both. So that means 2,000 times x, which equals 2,000x, and then 2,000 times 0.03, which ends up equaling 60. So therefore I have 2,000x minus 60, which equals 6,000. Now from there, since I have a minus 60, I have to add 60 so that this can equal 0, so that way I'm left with 2,000x on this side of the equation. And so for the other side of the equation, I have to do the same thing. I have to add 60 because that's the same amount as what I added on this side of the equation. So 6,000 plus 60 is 6,060. And so now to get the x by itself, I have to divide by 2,000. And when I do that, x ends up equaling 3.03. And when you plug it back in, if you subtract that and then multiply it by 2,000, you will end up getting 6,000. So for 2, again, I have to do 2 times x, which is 2x, and 2 times 1.25, which is 2.5, equals to 3.5. I have to subtract 2.5 from each side. So 3.5 minus 2.5 is 1, equals to 2x. Divide both by 2. And so I end up getting x equals 1/2. Or if you use a calculator, x is equal to 0.5. So for number 3, I have 1/4 times 4. So 1/4 times 4, put it over 1, equals to 4 over 4, which is equal to 1. And then 1/4 times x is equal to 1/4 x. So I have 1 plus 1/4 x equals to 4 over 3. If I subtract 1, I have to turn this 1 into the same denominator that 4/3 is on, which is 3's. So 1 equals to the same thing as 3 over 3. So I have 4 over 3 minus 3 over 3. So 4 minus 3 is 1. So 4 thirds minus 3 thirds is 1 third. And so I have to put equals to negative 1/4. Sorry, 1/4 x equals to 1/3. So then I have to divide by 1/4. And so when I do that, I keep this the same, and then I multiply by the reciprocal of 1/4. So if you flip it, that's the same thing as 4 over 1. So 1 over 4 is 4, and 3 over 1 is times 3 is 3. So 1 times 4 is 4, and 3 times 1 is 3. So I have to flip that back into a mixed number. So 3 goes into 4 one time with 1 left over. And so I have 1 1/3, which is x. So I have 2 more problems to go. So 10 times x, negative 10 times x is negative 10x. Negative 10 times negative 1.7 is a positive, because the negative times the negative is a positive. A positive 1.7, which is, the positive 17. So negative 10 times negative 1.7 is a positive 17. And then it equals to negative 3. So then I have to subtract 17. So I get down into deeper negatives. So I have to add this. So 17 plus 3 is 20. And I keep my negative. So then write the other side of the equal sign. Then I have to divide by negative 10. So x equals to positive 2. Because again, negative divided by a negative is a positive. That one was pretty easy. So now my last one, I have 0.3 times x, which is 0.3x. 0.3 times 8 is, oops, I keep messing up, 2.4. And then write your equals to 5.4. So subtract 2.4. So 5.4 minus 2.4 is 3. And I bring down my 0.3x. And I divide by 0.3. So 3 divided by 0.3 is, let me figure it out. So I have 3 divided by 0.3. I move this over 1, so I have to do the same thing right here. So that's 3 goes into 30 10 times. So your answer is 10. X equals 10. And so from here, you have to do numbers 1 through 5 on pages 58 and 59. And on a separate classroom post, I will have you post your answers. Just put number 1, this is the answer. Number 2, this is the answer. So on and so forth.